Hello everybody, Kevin Dennis, Gravitec Systems Incorporated. Welcome back to all of those of you who have been following us for the past couple of weeks. If this is your first time with us, every Thursday, every other Thursday at this time, we've put out some live stream video on some fall protection, rope access, or rescue topic. We record them, we upload them during the pandemic. It's just our way of keeping fall protection training, education, and services at the forefront. It's a way to stay connected with you, you to stay connected with us, and it drives website traffic, and it's all good things. I highly encourage all of you, if you find value in these tidbits, if you will, these little videos, feel free to use them for safety committee meetings, toolbox talks, incorporate them into your internal training efforts, however you see fit. And like any time, please feel free to reach out to anybody here at Gravitec Systems if you have any questions, issues, or concerns, or anything else. All right. So today we're doing something a little bit different. We're going to blow up some stuff. We're going to break some gear. We're going to highlight the use of our testing lab. And we're going to do a bunch of drop tests and static pull tests to kind of simulate what we see happen sometimes in the field when equipment is either grossly misused or it's old, dilapidated, or damaged in some manner. Okay? So first of all, these are not tests dealing with the quality of equipment. Okay? So if you can identify the manufacturer that it's in it, we're not doing these tests to test the quality of the equipment, because I and this test lab, we can break everything. We can break any pieces of equipment. So we're going to do these tests to hopefully, like I say, give you some tidbits as to what the equipment does in the real world. So let's get right to it. The first test we're going to do is what I call a run-out test. Everybody's familiar with self-retracting lifelines. There's kind of a trend, if you will, that small fall limiters and personal fall limiter devices are replacing the 6-foot energy absorbing lanyard, as they're being sold and marketed as a better product because they will reduce your clearance requirement, which is true, providing it's overhead. So one of the issues that we find with self-retracting lifelines, or the small units, is the coil spring inside of it. Eventually it wears out, and you get what's called run out. So if the unit is hanging up or off the back of somebody's harness, and you start seeing a couple feet of webbing, you know, or 3 or 4 or 5 feet of webbing, just like a tape measure at home, the coil spring inside of it is wearing out, and it doesn't have the retraction tension to pick up the snap hook. So here's a little larger unit. It even gets a little more pronounced when you put a big steel snap hook on it. So all I'm doing is introducing a little bit of friction into this unit. You can see the spring tension isn't strong enough to really pull it up. So my point is, in the field, commonly you'll look up at heights and there you'll see a self-retracting lifeline with 2 feet or 3 feet of slack in it. This is even also an issue if you're on a ironworkers horizontal lifeline. The SRD is a foot or 2 above that lifeline. Also an issue with leading edge self-retracting lifelines, or if they're being used in an aerial lift where somebody bounces out. So once you introduce slack into a self-retracting lifeline, it no longer functions like a self-retracting lifeline. The whole idea is that spring in there keeps this under constant tension. So no matter where you're working, you're always on your shortest possible line. So once you introduce some slack, bad things happen, and that bad thing, we're about to see what can happen. So what we're looking at is the orange weight is 310 pounds, and I've pulled all of the webbing out of the self-retracting lifeline. It's just under 6 feet long, and we're doing basically a 6-foot drop into a fall limiter. I have no idea what's going to happen. I suspect we're going to see some fireworks occur, and actually I'll be asking some questions as we go along through each of these tests. I encourage all of you to try to predict, you know, what's going to happen. So type in there if you want right now, is it going to fail? Is it going to hold? And for the really brave, you know, at what number or what poundage is it going to fail, or is it going to hold? So 310 pounds, going just under 6 feet into a fall limiter. Right. Think we're ready? You got the right shot there, Chris? Okay.
Good to go?
Whenever you're ready, Kyle.
All right, starting test. Data's reading. Safety's off. Dropping 3, 2, 1. Stopping test.
Wowza. Okay. So that was intentional, everybody. Again, I don't want you thinking that, hey, all fall limiters are going to fail or that this manufacturer makes a bad unit. If we did this extreme a test with virtually all fall limiters, we would see the same result. But we do see this in the field of an older unit and you have some slack in it. Because when you take a self-retracting lifeline, they're mechanical units. Okay? And when you run it right to the end, the only thing that's holding you on there is how the webbing is terminated on the axle. And that's ultimately we loaded up there. All of them are compliant to ANSI. You have to have a 3,600-pound termination, as well as OSHA requirements is down to 3,000 pounds. So it tells us we exceeded 3,000 pounds on this drop. And like I said, we did it on purpose. So what did we get for a failure point, Kyle?
Failure point was just under 3,400 pounds.
Got it. So the whole thing broke apart about 3,400 pounds. And I actually think we've got a replay here because that all happens pretty quick. We're going to reset for our next test. We're going to watch the replay, and then we'll get on to the next one. Go ahead. It's a pretty violent drop. And it's a difficult predictor. One of the reasons we're doing is not only for the video production and staying connected and linking to Gravitec systems is we still find a great misconception that's out there of people think they're fine because they're tied off. Nobody would think they're fine just because they have their seatbelt on. Okay, so educate people. You got to work through the equipment within its capacities. This was extreme. It was 310 pounds, going 6 foot. We kind of knew it was going to fail. But that's a reality. If you see slack in these self-retracting lifelines, this is what can happen. All right. So the next test we're going to do is we're going to pull an old lanyard. I've got 2 6-foot adjustable length lanyards. This particular one here was manufactured in '08, so it's 12 years old. Everything's still functional on it, but it was taken out of service due to its age, and I've got some paint that has saturated through the webbing and hardened. That's usually an indicator to get rid of the piece of equipment because the hardening of the paint reduces the elastic properties or the pliability or the hand, if you will, of that webbing. So this one was taken out of service, but on the surface, it's still all intact. So I'm going to hook it up in the static test bed, and we're just going to pull it. You're going to see the shock absorber rip out and deploy, and then we're going to pull it till it fails. So here's the next question for all of those that are watching. At what number do you think it will fail? All right. This particular lanyard for ANSI and CSA has to hold 5,000 pounds. However, like I said, 12 years old, bit dirty, and it's got paint on it. So again, please don't email me or text me or call me about or pass judgment on the manufacturer, because I can pull every manufacturer's product to failure. All of these tests are just for smiles and giggles, you know, to give us some content. And although I tell you that these tests aren't scientific, we're certainly doing it in a scientific environment. This is Gravitec Systems ISO accredited test lab. We're accredited through ISO 17025, and the vast majority of fall protection products are underneath our scope of testing. So if you have product that you want tested, if you're a manufacturer and you're looking for third-party accreditation of testing of products, reach out to us. We've got all the facilities here where we're able to do it. All right, we'll get set up for the next one. I'll probably walk over there, Chris, if you like. All right. Okay, so what we're looking at here is our static test bed. We've got a hydraulic ram, and we're going to pull this until it fails. I've got a steel cable, swivel just to keep the equipment aligned correctly. And I've got a load cell. Okay. So again, type in your comments, when do you think it'll fail? Brand spanking new, out of the box, it'll hold 5,000 pounds. But it's 12 years old, it's a little stressed, and it's got some paint damage. So, great. Whenever you're ready, Kyle, we can start it up. Guess I should have turned that on for you, huh? So as we pull on this, everybody, you'll see it come under tension, and then you'll see the shock absorber start to rip out. We'll just continue to pull that until it pulls out all the way. There you can see it, hear it pulling. There you're getting a slow motion action shot of the peeling action of that tear tape. So when somebody falls, or depending on how much they weigh and how far they fall, is how much of that shock absorber they're going to rip through. And then behind that white material is the yellow material, and that's actually your backup strap. And that's what gives the lanyard a 5,000 pound strength. So you can see we're stressing it. So we pulled the shock absorber portion completely apart, and now we're just basically onto a static web. And we're just going to keep inching it along until it breaks. There you can hear the stitching starting to pop, a little bit of popcorn action. There's one of them. Still holding.
What are we at, Kyle, weight-wise?
4,300 pounds.
We're at 4,300 pounds, and it's starting to stress. It'd be interesting to see the comments if anybody said, "Oh yeah, it's going to hold." We might make it.
Now to throw in the ram.
That's all right. We can relax it, Kyle. We're out. So that's pretty good. Are we able to reload a different cable in there and keep pulling it?
Yes.
All right, let's do that. Okay, so one of the happy things or one of the fun things about doing a live event is you can see whenever something doesn't go right. All that happened, everybody, is it continued to stretch, and we run out of throw on our ram. So here in 2 minutes, we're just going to throw in a shorter cable and then pick up where we left off and continue to pull it to failure. But you heard it got up to 4,300 pounds. And generally speaking, I'd tell you a lot of this material is stronger than what we give it credit for. That lanyard, what did I say? It was 08, so 12 years old. Everything's still intact. It's a little stressed. We're at 4,300 pounds and it still didn't fail, which is pretty good. But please don't think of this as me endorsing using 12-year-old equipment, using equipment that's soaked in paint. To some degree, we just got lucky that it held on to that amount. Whenever you're inspecting your equipment, you have to be conservative. You have to throw away the equipment before it hits its, life expectancy. And that's always a subjective decision. How much paint is too much paint? how much dirt is too much dirt, you know, how much frays or cuts is too much. There's very few definitive guidelines like that. So when you're inspecting your gear and you go, boy, it's 12 years old, it's got paint, you know, get rid of it before you cross that line that it's actually gone too far. So. All right, hold on a sec. As we're resetting for a shorter cable, I'll actually set up the next test. We're going to do the same thing, a static pull, on the exact same model of lanyard. That's why I picked these. I had two of them that were identical, at least in model. So this one is even older. This one was built, I believe, in '01. So we're 19 years old. We've got the old style snap hooks, if anybody's familiar with this manufacturer. An old ANSI energy absorber, so it'll rip out even less. The webbing's in very similar condition, but there's this nick in the webbing. I don't know if you can see that there, Chris. So I tell you, about a third of that webbing has a gouge out of it.
5K, because it's going so high.
Oh yeah. I'm back on. All right, welcome back. That was our COVID break. Washington State came in and said we hadn't tested this lanyard for COVID-19 yet. Since then, we've got it all tested and we're back up and running. All right, so where we left off, I was challenging everybody as to make your predictions as to when this lanyard will break. Give you an update on this one, we're actually at 5,700 pounds. Even I'm a little surprised at that, as most of these lanyards, when they're manufactured, they just barely get over the 5,000 pounds. That's where the manufacturers have them breaking at. And that being that old with that much stress on it, that's pretty good. All right, so I think I left off telling everybody, same model of lanyard. It's a little older. It's 19 years old, and it has probably about a third of a cut through the length of that webbing. So we're going to back up a little bit, continue to pull this one until it fails. We reloaded our ram. We've got enough throw to pull it to destruction. Then we'll put this one in. Go ahead, Kyle.
All right.
Go ahead and read out weight, like what you're looking at.
All right, we're just passing 4,000 pounds. We're up to 5,000 now.
So we're at 5K. You can hear it.
6,000.
6,000 pounds. Well, that was exciting.
That was at 6,100 pounds.
So 6,100 pounds. So 6,100 pounds, everybody. That's phenomenal for a piece that's 12 years old. It failed at the sewing end of the termination, which isn't uncommon, is when you have a piece of webbing, it gets its strength from being full thickness across all of its lays of material. So oftentimes, once you run a sewing needle through them, although it's still a 5,000-pound strap, that's where the webbing is technically the weakest. So that's pretty surprising. So again, I show people this, that equipment is built to be durable. It's very strong. You will get a certain amount of life out of pieces of equipment. It's designed to be that way. Certainly avoid neglecting it, but get rid of it well before you get to that point to where you're concerned about it. Okay? All right, I'll put the next one in here. Are you going to do a replay, Chris? Great. While we're reloading, Chris will replay that failure. Good. All right. So I'm not looking at everybody's comments, but I've got a hat or a t-shirt if somebody actually predicted, what did we get, 6,100 pounds? Yep. All right. So the next test, same test, static pull. Lanyard's 19 years old, same condition, but it's got a cut in the webbing. So we get set. And although there was a neat explosion there, everybody, what you don't see off camera is everybody's behind blast shields. All the staff are off in secure areas. It's not uncommon that you have a piece of webbing or something go flying like that. All right.
Starting test.
Starting test. So same thing. You'll see the shock absorber deploying. What numbers are we getting there, Kyle?
800 pounds.
Right. So that's quite predictable. Shock absorber, as it's ripping apart, or less than 900 pounds. It's floating around that 800-pound mark. So there we've exceeded the length of the shock absorber. The energy absorber portion, the tear tape, fails. And now we're doing a static pull on the backup strap of the lanyard. And the webbing of the lanyard portion has got that cut in it. Might be a little difficult to see, but I'm looking at it. It's opened up to a good inch, but still holding, and here it goes.
Just over 2,000 pounds.
How much?
2,000.
Got it. So we're at 2,000 pounds, just over, and you can see it's failing. You see the fibers starting to fall apart on it.
We're at 3,000 pounds.
We're at 3,000 pounds. It's coming apart like my carpet. And it breaks.
Just over 3,700 pounds.
All right, so it broke just over 3,700 pounds. So 3,700 pound failure, that's well short than the 5,000 pounds. But again, this equipment is built to be durable. Please don't assume just because it held, 3,600 pounds that cuts in your webbing up to 1/3 of an inch are acceptable. That is not the takeaway from this little demonstration. Whenever you see cuts or tears, because not all the webbing is the same, and what happens is when you have webbing, it has its strength on its full thickness. So when I put a cut in it, like you saw in the test, it opens up. So when that is open, I might only have, all of the load on maybe 3 or 4 of those strands within the webbing. Harness webbing is different, lanyard webbing is different, SRD webbing is different. So again, I can't caution you enough that I don't want people to go, hey, a test we saw at Gravitec says I can have a third of a cut in my lanyard webbing and it still holds 3,600 pounds. No, not the case. It still failed. And that's too fine a line to be operating your equipment on. Oh, that one's pretty cool. Did you show a replay, Chris? So you can see as we increase the strength on it, as that cut just opens, as it hits the next strands of fibers, it continues to break until enough of them break where it finally gives up. All right, I think we got two guys, Jason Denton, that's pretty darn close. Said 4,800 pounds for the cut one. However, this is like the Price is Right, so it's closest number without going over, so you're over a bit. I'll still send you some swag, Jason. And then Steve Steele's also pretty close at 2,400 or 2,600. All right. The last test we're going to do is overcapacity of a shock absorber. This is probably one of the most common misapplications that we see. And since today is the day that we're blowing stuff up, we're going to go Mythbusters on it and go way overboard. So when I get out of screen here, you'll be able to see the next drop test is a 12-foot free fall on a 6-foot capacity energy absorber. Okay, so we've got a 310-pound weight, free falling 12 feet into the wrong energy absorber. We should again see some fireworks. We'll fully deploy it. So the challenge to everybody to type into the comments section is how much force do you think we're going to realize? We've got 310 pounds going 12 feet into a 6-foot capacity energy absorber. That energy absorber is going to have a deployment force, in that 700, 800 pound range. But we're over the free fall distance by 6 feet. So we should blow through that pretty quickly. Your challenge is to what's going to be the residual energy, how much is left over. And you might even comment whether you think the whole thing's going to fail or not. So we're going to get reset. So as we're turning on the computer and everything here, a little plug for our test stand. That's an ISO compliant test stand to 17025. I can do just under 30-foot free fall drops. Then I've got a static ram where I can pull up to, I think it's 20,000 or 30,000 pounds. I've got all of the necessary load measuring equipment where I can have a sampling rate, dialed right down or cranked right up. I think I can go anywhere from 100 to 15,000 samples per second. Some of the things that you don't see are in the background. I've got an environmental test chamber. So if there's tests that people want done where it's you're in extreme environments, you want to freeze something, you want to heat it up, you want to get it wet, you want to run it through salt water, and how will that lanyard or SRD perform at 80% humidity when it's 110 degrees outside? I can do all of those tests here at the test center. So are we ready to go, Kyle?
Yep.
Chris?
Yep.
All right. So what we're looking at, oh my goodness. The orange weight's 310 pounds. It's going to fall about 12 feet. And actually behind that test weight is our safety line. We've actually got multiple shock absorbers hooked up to the safety line just in case we blow through the whole lanyard. So last chance to enter into the comments section what you think the residual impact force is going to be and whether the lanyard's going to fail or not. All right, I gave you the token 5 seconds to enter in your comment. Go ahead, Kyle.
All right, starting test. Data's reading. Safety's off. Dropping 3, 2, 1. Stopping test.
All right. So that was actually pretty good. It did as predictable. I had thought we might have had enough there to break it. But as you saw, test weight drop obviously blew through the entire shock absorber. Weight hits the end of that backup strap, the same one that we saw that we pull tested. And that bouncing energy, that's creating injury. If this was a real application of a worker, if you weigh too much or you fall too far and you fully deploy a shock absorber, you're going to have what I kind of call is the leftover energy or residual energy. What did we hit?
Just under 3,900 pounds.
So 3,900 pounds. OSHA has a mandate, is whether every state has a mandate, that the maximum arrest forces on worker can't exceed 1,800 pounds. Okay, that seems to be the accepted injury threshold. You're going to survive 1,800 pounds. Injury, generally speaking, starts to occur at this 2,700 pounds. So if this was a real-life application, person misapplied the equipment, or they weighed too much, or they fell too far, and we see this frequently. People connecting two lanyards together, adding a lanyard onto the end of an SRD, where you just have these monstrous free falls. It's all energy. Your body wouldn't have survived 3,800 pounds of resting force. Now you're hanging in that harness injured, and you still have to be rescued. And imagine all the manipulations that are going to go on in your body as you go through that rescue. So the equipment performed pretty well. We didn't fail it. 3,900 pounds, and we got some fantastic destruction footage as a part of it. So thank you very much, everybody. Enter information in your comments. I think we're going to go to the group and to see if they have any questions. And I think you probably want to show a replay too, Chris. All right. I will be going through all of the comments, and if you have any questions, and I'll surf through it, and I'll send a couple of you, like I say, some Gravitec swag. Hopefully you saw something interesting, and I want you to have the takeaways here is inspect your equipment frequently. Get rid of it before it comes damaged. But the equipment, and if you're buying right from reputable manufacturers, is still pretty tough. So thank you very much. We'll see you. Pay attention to your email boxes. We'll let you know when the next session is going to be. All right, bye for now.